Hello everyone, I am Indrajyoti Gaine. I am a PhD student at Department of Mathematics and Statistics, IIT Kanpur. Presently, I am a PMRF fellow. Before that, I was a CSR fellow. I have cleared my CSR net with 108 rank. So, in last classes, we have discussed about straight lines, how we can obtain the equation of straight lines in different form, and also we have discussed about its intersect form and at which point a straight line intersects either axis. Also, we have discussed about the slope of the tangent and using the slope of the tangent, the slope of the straight line, how we can get the equation of the straight lines. And in the last class, also we have discussed about the distance of the any straight line given in some simplified form. That we can measure a distance of this straight line from a given point. So we will use that thing, and also we have discussed about the distance between two parallel lines. Okay, so let us today start with the recall of the two concepts, not everything. Just recall the fact that if equation of a straight line is ax plus by plus c equal to 0, then the distance of this straight line from a given point x1 comma y1 will be will be ax1 plus by1 plus c square root of a square plus b square whole mod. So this will be the distance of the point x1, y1 from the straight line, and this distance is corresponding to the perpendicular line. Okay, so this must be a perpendicular line from the given point on the given straight line. Suppose this is our straight line, whose equation is given in this form like ax plus by plus c equal to 0, and this is the given point x1 comma y1. Then this distance, the distance d, is nothing but the length of this straight line. This perpendicular straight line has length d, and this is corresponding to the shortest distance between the given point and the given straight line. And also we have discussed about the fact that when we have two parallel lines, suppose this is our two axis, this is our y-axis, and this is our x-axis, and suppose we have two parallel lines like this, one is this and another is this, and since they both have same slope, if we write it in this form like intercept form, then the equation will be of the form like y equals to mx plus c1, and another one will be y equals to mx plus c2. Here we note, one should point out that this m should be equal. Why? Because the lines are parallel, so their slope will be same. Now, in the last time, we have discussed about the distance between these two straight lines, and the formula was kind of like this. Yeah. So, modulus of c2 minus c1 divided by 1 plus m square. Okay. So in today's class, we will discuss few examples regarding these straight lines and their distances between the distances. So the first question comes: find the distance of the point 3, minus 5 from the straight line 3x minus 4y minus 26 equals to 0. So what we need to do? We need to use the formula we have formulated here, right? Because the equation of the straight line is given and the point is also given. So we just need to find the distance of this point from this straight line. So for that, here, just if we compare with this equation with the generalized version of our equation of the straight line, then we obtain here that this together implies a equal to 3, b equals to minus 4, and c equals to minus 26. Okay, now we can apply the formula here. So what was that formula in our case? That the distance between the lines was modulus of ax1 plus by1 plus c square root of positive square root of a square plus b. This square root should be positive square root. Okay. Now put the values here. 3 into what is our x1? 3. So 3 into 3 plus what is our b? B is minus 4 into what is our y1 minus 5 plus c. C means minus 26 divided by square root of a square plus b square, that is c square plus minus 4 whole square. This implies 6 is a 9 plus 20 minus 26 whole modulus divided by 9 plus 16. So this will give us 29 minus 26 modulus divided by 25, which further give us c divided by 5. So from here we can say the distance of the point 3, minus 5 from the straight line 4x minus 3x minus 4y minus 96 equal to 0 will be 3 by 5. Distance will be 3 by 5. Next question. Find distance between two lines y equal plus 7 equal to 0 and 3x minus 4y plus 5 equal to 0. Okay. So we have given by two equation of two straight lines. Now what we need to find? The distance between these two straight lines. Now the first question comes here. that thus these two straight lines are parallel. So for that, what we need to check that the slope of the two straight lines are same. For that, what should I do? So let us rewrite these two equations in different form. So if I rewrite this equation, it will look like 3x plus 7. This is equals to 4y, or it can be written as 4y equals to 3x plus 7. Both sides divided by 4, which further implies y equals to 3 by 4 x by 7 by 4. Okay. Now what about this? Similarly, we can here also you can write like 4y equals to 3x plus 5, which further give us y equals to 3 by 4x plus 5 by 4. Okay. So from here and here, it is clear that these two terms are same. That is, we can apply this formula, or in general, we can say these two straight lines are parallel as they have the same slope. Now, according to the formula, what was that? The formula was y equals to mx plus c1, and this was y equals to mx plus c2. So here m equals to c by 4, c1 equals to 7 by 4, c2 equals to 5 by 4. Okay. Now, if I use the formula between them, then the distance between these two parallel lines be modulus of 7 by 4 minus 5 by 4 square root of 1 plus 3 by 4 whole square, which further give us 1 by 4, 7 minus 5 divided by 1 by 4, 4 square plus 3 square. Okay. So 1 by 4, 1 by 4 vanish, and ultimately we get 2 divided by 3 square plus 4 square. This is nothing but equals to 5. So the distance will be 2 by 5. Okay. So here one can directly use this previous formula we have written in the last slide, that this one can easily use mm, this equation or this formula finding distance between two straight lines. But for that, you should be clear that this a and b should have same value, or they give the same slope of the tangent. Even the value of the a and b are same, but the signs are different. That can also be a matter of to check that these two lines are parallel or not. So it will be better to write it in the form in y equals to mx plus c, so that you are clear from the value of m that the slopes are the two straight lines are always equal, and or they are equal. Therefore, they should be parallel. From there, you can use the formula like this formula to get the answer. This will be more convenient to do. Otherwise, one can use this one. Let's go to the next question. The next question is, find the points on the x-axis whose distance from the straight line. One is given as 4 units. Okay. So what we need to find, that we need to find all those points on lying on the x-axis, such that the distance of this point on the x-axis from the given straight line will be 4 units. Okay. Now let us draw the equation first. So if these two are axes, x and y, so x will be like 3 comma 0, and that will be 0 comma 4. The straight line will be something like okay. So this is our the straight line, and what you need to find, that all those points whose distance to the straight line from the x will be 4 units. So from here, one can say that one point may be at this point, from where we can have 4 units like this, and another point can have like somewhere here or somewhere here, like I don't know where it is, but 2 point we can get, such that the distance from that point to the straight line will be a 4 unit distance. Okay. Now how can I do that? So any point on this x-axis will have coordinate, suppose a comma 0, right? So any point on this x-axis should be coordinate a comma 0. Now what we need to find? We need to find the value of a. So for that, what can we do? First, this is an intercept form. This straight line equation is in intercept form, so we will rewrite it in general form. So if I rewrite it, what I will get, x plus 3 y by 4 equals to 1. So this will give us 4x plus 3y 12. This will ultimately give us 12 minus 12. This equals to 0. This will ultimately get. Now, any point on the x-axis is coordinate a comma 0. So from this point, if I find the distance of this straight line, what will be the distance? So the distance of this straight line from the point a comma 0 will be 4a plus 3 into 0 minus 12 divided by 4 square into 6 plus 6. Okay. So ultimately we get 4a minus 12 mod divided by 5. And according to the question, this d is nothing but 4. Okay. If I simplify it, we will ultimately get 1 equals to a minus 3 by 5, because this can be written as 4 into a minus 3 divided by 5, and we can vanish 4 from both sides. So that's why we have written 1 equals to a minus 3 plus 5. Now here for modulus, we have to work with two cases. One case is 1 equals to a minus 3 by 5, And another case is a equal 1 equals to minus a comma 3 divided by 5. So from here we obtain 5 equals to a minus 3, which implies a equals to 3 plus 5, 3 plus 5, which is equals to 8. And from here, what do we will get? We get a minus 3 plus 5 equal to 0, which ultimately give us a equals to minus 2. So from here, using the formula of the distance and by the information using in the given question, we can clearly say that A can have 2 points. A equals to either 8 or equals to minus 2. From here, we can say the coordinate of such points on the x-axis is the of such points on the x-axis will be 8, 0 or minus 2, 0, such that the distance from these points to the given straight line will have distance 4 units. Okay. Now let's go to the next question. The next question is, if 3 points h, 0, a, b and 0, k lie on a line, then show that a by 8, b by k equals to 1. So this is a very straightforward question. If one can observe the question properly, then it is a one-liner. Or if someone couldn't observe the question, then he can do it some few steps. So I will first do with few steps, and then I will tell how it can be done in just one line. So what is the question? That if 3 points, given 3 points are lies on a straight line. So this means if I consider any 2 points, we can get the slope of the straight line. Like if I consider these 2 pair, or these 2 pair, or this one and this one, whichever we consider, we will ultimately get a quotient of the slope or value of the slope of the tangent of the straight line with the positive x-axis with anti-clockwise direction. Right now, since the 3 points are on a single straight line, therefore the slope of the 2 cases will be equal. Hence, from here we can clearly use the fact that the slope of the straight line is fixed. Therefore, one can use this fact as like one slope will be b minus 0 divided by a minus h. This is one case. And what is the another case? Another case will be k minus b into 0 minus. So how we have done? We have first considered these 2 points and next considered these 2 points. Okay. Thus, we have obtained these two slopes and we have made it equal. So, from here, if I do the calculation, what I will get minus AB, this is equals to A minus H, K minus B. This ultimately give us AK minus AB minus HK HB is equals to minus AB. This get cancelled and ultimately we get AK plus BH is equals to HK. And if I divide both sides by HK, we obtain A by H, B by K equals to 1. So this is the required relation demanding in the question. Now, this is using just few steps. Now one can use the one-liner. How can they use? So first of all, look at these 3 points. If this is your axis, so 0 comma h comma 0 will be somewhere here. It depending upon your choice, it can be on negative axis also. But in general, you can consider this on the positive axis because you don't know the value of the h. So it is general. You can consider that h is a positive value. Similarly, on y-axis, this is the coordinate of 0 comma k. Okay. Now, from here, one can easily see we obtain an straight line, and that is saying that a comma b will be another point on the straight. So at this moment, just forget about this a comma b. Okay. Now, whenever we know that a straight line intersects the x-axis and y-axis by h comma 0 and 0 comma k, then the equation of the straight line will be of the form x by h y by k equals to 1. Now, from the given statement of the equation, one can say that a comma b also satisfies the equation of this straight line. So from there, we can easily imply that since the point a comma b satisfies the equation of this straight line, therefore a comma h b comma k should be equals to 1. Okay. So this is just one line proof, and in the exam, if someone can observe it properly, then it can be done in just few seconds, which is the equation of the statement. Otherwise, one can do it in some step by step. That then also you will get the proper answer. Now, in the last class, we have discussed about the angle between two straight lines. What it is? Here. Yes. So here we have used the how you can define the angle between two straight lines. So let us do one simple example regarding this concept. The question is, the slope of a line is double the slope of another line. If the tangent of the angle between them is 1 by 3, then find the slope of the line. What is the question? They are asking that there are two straight lines whose has that one has slope twice of the other. So if one has slope m, then other should have slope 2m. Now, according to the question, that the tangent of the angle between the given two straight lines is 1 by 3, then we need to find the slope of the given straight line. Okay, so how we can do it? So first, because that if the angle between two straight lines is theta, then we derive this thing that tan theta equals to modulus of m1 minus m2 divided by 1 plus m1 m2, where m1 is the slope of the first line and m2 will be the slope of the second line. Okay, now what is the question here? That one has slope twice the other. So if m1 is our p, then m2 will be 2p, and obviously here tan theta equals to 1 by 3. Tan theta equals to 1 by 3. So if I put all these values in this given formula, what we will get? We will get 1 by 3. This is equals to p minus 2p divided by p into 2p. Okay, so this will ultimately give us modulus of minus p 1 plus 2p square. Now since we have the modulus, so we can clearly say from here that two cases arises. What? One case is 1 by 3 equals to minus of minus p divided by 1 plus 2p square, and another case is 1 by 3 equals to minus p divided by 1 by 2p square. So these are two cases we can find. Now let us simplify all these things. So in this case, if I simplify it, what we will get? 1 plus 2p square. This is equals to 3p. Ultimately gives 2p square minus 3p equals to 0. So if I factorize it, we will get 2p plus 1 sorry, 2p minus 1 should be there. Let's do it once. 2p square minus 2p minus p plus 1. So if I take common, I will get 2p p minus 1 minus 1 p minus 1 is equals to 0. This will give us 2p minus 1 into p minus 1 equal to 0. So this will give us p equals to 1 or half. Okay, p equals to 1 or half. Now if p equals to 1 and half, then clearly we can say m equals to either 1, then m2 will be 2. If m1 equals to half, then m2 equals to 1. This is one case. What about the other case? If I calculate it, we will get 2p square minus 3p plus 1. This will ultimately give us 2p plus 1, p plus 1 equal to 0. This will give us p equals to minus 1 or minus half. So in case if m1 equals to 1, then m2 equals to minus 2. If m1 equals to minus half, then m2 equals to minus 1. M2 equals to minus 1. Okay. So from here, we have obtained all possible cases of slopes such that the angle between two straight lines can be of tan theta equals to 1 by 3. Like the angle between the two straight lines will be like that, such that the tangent will be, the tangent of the theta will be 1 by 3. Okay. So this kind of question can be approached in this way. Let's go to the next question. The next question is, find the distance of the line 4x minus y equal to 0 from the point P, which is its coordinate 4, 1, measured along a line which makes an angle 135 with the positive x axis. Okay. So what is the question? We need to find the distance of the straight line 4x minus y equal to 0 from the point P, which has coordinate 4, 1, which is measured along a line which is with an angle 135 with the positive x axis. Okay. So first, draw the graph. X, y. So first of all, this straight line passing through the origin. So one is the origin will be 1 point, and another point will be if our x equals to 1, then y equals to 4. So like this. So using these two straight lines, one can say, these 2 points, one can say the straight line will look like something like this. Okay. Now, what is the point 4, 1? 4, 1 point will be somewhat like 1, 2, 3, 4. Somewhat like here. Okay. And we need to find a distance of this point from the given straight line along the line which makes an angle 135 degree. So the case is we need to draw another straight line. Suppose this is the straight line passing through the point 4, 1 such that this angle is 135 degree. This angle is 135 degree. And what we need to find? We need to find this length. We have to find this length, this value of the d. Now the question is, we can use the formula of the distance because we know the distance of a point from the straight line, given straight line. We have a formula, particular formula we have. But the problem is there that those distance were length of this line, the perpendicular line from the given point. But here the question is that along the straight line, which makes an angle 135 degree. Then how can I do this problem? How can I solve this problem? So let us think something. That point was there. So this point has coordinate 4, 1. So the idea is, if we can find the coordinate of this point, then we can find the distance between these 2 points. Fine. So how we can find the coordinate of that? For that, we know about the equation of this straight line. This straight line is equation y equals to 4x. Right? Now, I need to find the equation of the dotted green line. For that, one thing we have that the straight line passing through a point 4, 1. So the equation of the straight line will be equation of the straight line passing through 4, 1 and making an angle 135 degree with the positive x axis will be y minus 1. This to 10, 135 degree into x minus 1. Now 10, 35, 135 means this is in the, this should be negative value. This should be negative value because the angle is obtuse angle. Therefore, and this value is actually minus 1. So ultimately we get y minus 1 is equals to minus 1 into x minus 1. This will give us y minus 1 minus x plus 1. This will ultimately give us x plus y sorry, I have done something mistake here. Okay. Equals to x minus 4 would be there. Minus 4 plus 4. This will give us this equation. So we obtain this equation and we already have this equation. Okay. Now, what next step? Next step is we need to find a point of intersection of these two straight lines. So for the point of intersection, suppose that this point has coordinate x1, y1. Then this point will satisfy the equation this one as well as this one. So let us write this. Suppose we have y1 equals to 4x1, and also we have x1 plus y1 minus 5 equal to 0. If I put the value of y1 in this point, in this equation, what we will get? x1 plus 4x1 minus 5 equal to 0, which will ultimately give us 5x1 minus 5 equal to 0. This will ultimately give x1 equals to 1. What we will get ultimately? Ultimately gets x1 equals to 1. Now using this, we can get y1 equals to 4. Right? So we obtain the coordinate of this point, which is 1 comma 4, right? This point is 1 comma 4. Now we have the coordinate of the end point of a line segment, this line segment. So clearly we can find the length of this line segment, and that will be using the formula. So here, hence d equals to square root of 1 minus 4 whole square root of 1 minus square plus 4 minus 1 whole square. So this will ultimately give us 3 root 2 units. Ultimately give us 3 root 2 units. Okay. So thus we can find a distance of a straight line from a given point with given some particular angle. This kind of question can also be asked in various exams. So you can approach these questions like this. Let's go to the next question. Next question is, assuming that straight line work as the plane mirror for a point, then find the image of the point, find the image of the point 1 comma 2 in the line s minus 3y plus 4 equal to 0. What is the question? Question is like they have given an equation of a straight line, and they have told that the straight line works as a mirror, and we need to find a reflection of this point 1 comma 2 in this mirror. Now the thing is, in general, if you think in the reality, we can't measure a distance from inside a mirror, but it is assumption. So what the question is saying, this question is saying that suppose this is our coordinate, and I am not drawing the exact equation of this straight line. So suppose this is our straight line. Suppose I'm not saying that this is the only equation of the straight line, because I haven't reduced it in the intercept form. So yeah, suppose this is our straight line. Okay. Now we have 1 point 1 comma 2. Suppose this point is here. Okay. Now what you need to find? We need to find a reflection of this point. So this reflection will be somewhere here, and this distance should be equal. There is a green line and a red line. Red line should be there. This red line should have same distance. So the green line and the red line should have same distance. Because as the mirror works like that, distance from the object from the mirror and same the distance from the object inside the mirror. This should be same. This should be same. Just the reflection will be some opposite side and all these things happen, but distance must be same, right? So here also this question is like same. So what is the question? The question is if this point has coordinate h comma k, then this straight line bisects this line at the midpoint perpendicularly. This is the main constant. Okay, so bisecting perpendicularly at the midpoint. Obviously, bisecting means midpoint will be there. So this will be the midpoint. And if HK be the location of the mirror image, then the bisecting point, the midpoint will be of the from h plus 1 by 2 and k plus 2 by 2. And this point will satisfy the equation of the straight line. So this will give us h plus 1 by 2 minus 3 into k plus 2 by 2 plus 4. This is equals to 0. This, if I simplify this, what will we get? H plus 1 minus 3k minus 6 plus 8 equal to 0. This will give us 8 minus 3k plus 3 equal to 0. One thing we obtain this one. Now another thing is the slope of these two straight lines will be perpendicular. Okay. Now what is the slope of these straight lines? This straight line can be written as like y equals to 1 by 3x plus 4 by 3. So slope is 1 by 3. And what is the slope of this straight line? This straight line has slope like k minus 2 divided by h minus 1. Now, according to the question, they are perpendicular. So, obviously, k minus 2 divided by h minus 1. This is into 1 by 3. This should be equal to minus 1. So, if I calculate this, we get k minus 2 is equals to minus 3 h minus 1. So k minus 2 is equals to minus 3h plus 3. This will give us 3h plus k is equals to 5. And here we obtain h minus 3k is plus 3 equal to 0. Now if I solve this one and this one, both the equation, if we solve both the equation, we can get the proper answer. So let's solve it. Here from here we can get this will give us h equals to 3k minus 3. To put it here, so from here we obtain this 3 into 3k minus 3 plus k. This is equals to 5. This implies 9k minus 9 plus k equals to 5. 10k equals to 9 plus 5, which is equals to 14. it implies k equals to 14 by 10, which is nothing but 7 by 5. So k equals to 7 by 5. And what is 8? 8 equals to, let's see, ultimately get 6 by 5. So the coordinate of the mirror image of the point 1 comma 2, if I assume the straight line as a mirror, will be 6 comma 5 coordinate 7 comma 5. This is the mirror image of 1 comma 2 if I consider the straight line as a mirror. So thus we can do or solve the questions of the straight lines, and just we can use the concept whatever you have learned in this chapter, and using that you can get the answers easily. Okay, so let's stop at this.